This is Climate Watch. I'm Zhao Ying. Welcome to the show. The Yangtze is China's longest waterway and the third largest river on Earth. Stretching 6,300 kilometers from the Qinghai-Xizang Plateau to the East China Sea, it feeds over 400 million people and drives 40% of the country's economy. However, decades of overfishing, habitat loss, and intensive human activity pushed many species in this vast river ecosystem to the brink. As a result, the Baiji dolphin, once known as the goddess of the Yangtze, was declared officially extinct in 2006. In 2021, China launched an unprecedented 10-year commercial fishing ban across the Yangtze River basin. Now, halfway through this experiment, scientists are seeing some surprising signs of recovery. A study published in the journal Science found that fish biomass in the river has more than doubled, and several endangered species have rebounded. Even the critically endangered Yangtze finless porpoise, the last remaining freshwater mammal in these waters, is making a visible comeback. How encouraging are these early signs? How do we ensure this fragile recovery becomes permanent? And what vital lessons can the Yangtze offer to other struggling mega rivers around the world? One of the authors of this study is joining us today. Chen Yushun is a professor at the Institute of Hydrobiology at the Chinese Academy of Sciences and Dean of the School of Life and Health Sciences at Hunan University of Science and Technology. Professor Chen, it's great to have you with us.
Thank you. I'm glad to be here.
Well, many rivers around the world have seasonal closures or protected areas, but a 10-year commercial fishing ban across an entire mega river basin is unprecedented globally. So why did China decide that such a dramatic approach was necessary?
As you mentioned, the seasonal closures or protected areas actually are very common in not only in China but in some other parts of the world. But we started the 10-year commercial fishing ban. It's a long history journey. We started the seasonal, closure of fishing ban from around 2002, in the lower Yangtze River basin. Then we moved from that then to about 19 years, to 2021, and we started the 10-year full year ban. In the past, the seasonal ban does not work very well because we started like 3 months and even 4 months closures, but after that the commercial fishing is open. Then pretty much all the fish have been caught to the bank, so it's not effective. So we have to, try something new, and some other countries have never tried, but it seems works.
Mm-hmm.
That's the journey for the fishing ban in China.
Okay. Your team evaluated the effectiveness of this large-scale conservation action by assessing fish communities across mainstem habitats before and after the ban. Can you walk us through the major findings?
Yes. The major findings, we found the increase of the fish biomass. I mean, the total weight of the fish. So what that means is each time we can catch many more kilograms of fish per net each time than before. And that's one of the biggest increase. And another one is we did see some, real fish species, they're coming out. So that's a very good sign, especially some large animals. For example, the Yangtze finless porpoise, the population is being increased a lot. So these are the major findings for our study.
Yeah, tell us more about the Yangtze finless porpoise. I mean, that is perhaps one of the most closely watched species in the Yangtze River. And I learned that your research found its population increased from 445 in 2017 to 595 in 2022. And actually, official monitoring data released earlier this year shows that the population has now surged past 1,400. How significant is this rebound, especially given that the finless porpoise is now the last remaining freshwater mammal in the Yangtze River?
Yes. One thing I wanted to make clear in here is our numbers from 445 to 595. That's only for the main stem of the Yangtze
Mm-hmm.
River. So the number you just mentioned, 1,400, that's for the whole Yangtze River basin. So basically, including the main stem and the two largest lakes and some of the reserves. So our data only showed the main stem. So that's the big difference. But it seems like we look at the main stem, it increased a lot as well. So it seems like this large animal, they can get more food, because no fish was caught by the fishermen, so they can eat more, and they grew very bigger, and also the population increased a lot.
Yeah, and when we look at the finless porpoise's recovery today, it's hard not to think about the Baiji dolphin. So I'm thinking if a policy like this had been implemented like 2 or 3 decades earlier, do you think the Baiji dolphin might have avoided extinction?
This is a very interesting question, I think. I would say we cannot absolutely say it can save, but at least it can help the Baiji if the policy being implemented, like 2 or 3 decades earlier, because the loss of Baiji is caused by the overfishing as well. But in addition to fishing, there are many other stresses. For example, the navigation. I mean, the shipping boats. A lot of turbines. The herd. So navigation and the fishing, there are two major ones are causing the decline of the Baiji. So if we have been implemented the policy like 2 or 3 decades ago, it definitely can help the Baiji. But the difficulty is, if you know this, Baiji is actually larger than the Finnish porpoise,
Mhm.
and its population is smaller than the Finnish porpoise. So it's hard to make a solid conclusion or prediction on that, but it definitely can help.
Yeah, and I think the data shows that actually larger body fish species actually benefited more from this fishing ban. Why is that? Why are the big fish bouncing back first, and what does that mean for the structural food web of the river?
Okay, that's a good question. Because in the past, even though the commercial fishing activity mainly targeting on all the species or all kinds of animals in the water, but the larger bodied ones are easily be caught and they can be sold, very good price. So, but right now, the fishing ban is implemented, so no fishing activity. So these large ones, they can, usually are these guys are, predators. They eat fish, they eat other fishes. So there are no, I mean, no people catch them, so they can eat more fish. They can grow bigger. That's the reason for that. And for the food web structure, right now, you know, in the first couple years, I would say it's a good thing because in the past we did not have many large-bodied fish species because already caught by the fishermen. Right now they are coming back, so they make the food web it's kind of more balanced. But in the coming years, we'll still need to watch for this trend, for this situation.
Well, most people think of ecological recovery in terms of numbers, like more fish, higher biomass, right? But beyond population size, does the fishing ban also help restore genetic diversity within species? And what does that mean for long term resilience?
That's a really interesting question. To be honest, we have not studied the genetic diversity into the population or the community right now in the Yangtze River, but it's really a very interesting thing to look at in the future. But if we, get more fish, more species, and more species are covered, there is a positive sign for the increase of genetic diversity. For example, some of the species we've been, lost. Seems like been lost in the river. We did not catch them for a long time. But after the 3 years of, 3 to 5 years, fishing ban, they're coming back. So that definitely will increase the genetic diversity.
Yeah, but we know that to make this ban work, the government actually scrapped around 100,000 fishing boats and helped more than 200,000 fishers transition to other livelihoods. From a conservation perspective, what lessons does this experience offer about balancing ecological recovery with the needs of local communities and the economy?
Yes, this actually is another aspect related to fishing ban. It's more, social, society related things because we have to move people from the boats to the bank, and we have to provide alternative jobs for them and their health benefits, some other, social, so, I mean, society related things. Um, so the lesson is, if we, you know, wanted to do this in some other river basins or some other countries when you learn from this, you definitely need to think about you know, the investment, need to have a balance between the ecological recovery and the local community needs. We need to solve their problems before we solve the ecological problem in the river.
So your research concludes that the fishing ban was like the primary driver of recovery, but there are also other improvements, like in improvements in water quality, reduced vessel traffic, and habitat restoration. So how much of the recovery can really be attributed to the fishing ban itself?
Yes, this actually it's related to one of the questions that you asked before. You mentioned the vessel traffic.
Mm-hmm.
That's the transportation. The fishing boats. A lot of commercial activities in there, transport goods. Along the river. Our model showed, fishing ban and some other factors, water quality, hydrology, vessel traffic, habitat restoration, they all played roles, in the recovery. But we found the fishing ban, it's like one of the most important factor they have, based on the equations, and we show they have pretty good impact on this. So if we want to get more quantitative information, we have to do more data to quantify them. But right now, based on what we have, we can definitely see fishing ban is one of the major one to the recovery of the fish resources.
Yeah, the results so far are certainly encouraging, but do early signs of recovery necessarily translate into long term ecological success? And what will your team be watching most closely over the next few years?
Yes. just like I mentioned earlier, in these past 3 to 5 years, we can just say it's an early initial recovery. It definitely can predict for the long-term ecological success. For example, if we keep this trend, and for another couple of years, we definitely will see the stable or long-term ecological recovery or success of this river system. But we use a term. It's called cautiously positive, or cautiously optimistic. So we have to watch for the coming years because in addition to the fishing ban, there are many other stresses. They are all coexisting. So if we control other stresses well, we definitely see a continued positive recovery trend.
What do you mean by the other stresses?
For instance, we still have the dams, in the mainland
Yes.
of the Yangtze. We have the Three Gorges, and there are many huge dams above the Three Gorges. They are existing there. They are operating each year. So the hydrological issue is still there. For example, some of the migratory fish species. One of the species we are interested in is the Chinese sturgeon. They are affected by the dams a lot, and some of the damages cannot be repaired. In addition to the dams, there are some other stresses such as the navigation still there, because we have to transport goods from the upstream to downstream. For example, from Wuhan to Shanghai, you need to, transport a lot of stuff, to downstream to the ports. And some also we have the very mega cities along the river, have a lot of human activities. So these are need to be regulated and controlled well.
Yes, indeed. But we know the current fishing ban is scheduled to last for 10 years, so there are still 5 years to go. But what is the plan after that? Is the expectation that commercial fishing will eventually resume, or could some form of long-term protection remain in place?
This is a very interesting question, but it's really hard question to answer. But I would say, right now, we are still doing this in the coming years. But after like couple years, when we reach the 10 years ban, 2030, then we need to look at how the population, how the fish community looks like. Did we still need some similar ban, or we have to adjust some of the policies? Right now, it's hard to tell, but from a long-term view, I actually discussed this issue with my colleagues, in other countries, when we worked together for this project, and they mentioned that, it's maybe there have some, economical or social related things for the long term issue to put this ban for many of years, but we may have to adjust to certain aspects. But we definitely will not go back to the past. If we go back to the past, then we will lose many more species as well. So.
Yeah, so you've been watching those for many years, and I'm just wondering whether you are surprised by how fast it is bouncing back, because we often hear about ecological tipping points. The idea is that once an ecosystem degrades past a certain point, recovery becomes extremely difficult. But the Yangtze River was in decline for 70 consecutive years, and it turned around in just a few years. So does this suggest we might have been underestimating the resilience of large-scale ecosystems?
Okay, this question, it's kind of interesting because in the past, we, from 1950s, from right now, it's about 70 years. In the past 70 years, we see, when you look at the trend, the population or the community structure, it's all dropping. Many of the species, many of the biomass, the numbers are being dropped a lot. So in biological conservation, we have a term, it's called bending the curve for biological loss. But right now, we are not getting to that point yet. We are just around a point we see the loss is just stopped. We're not come back yet. Well, we have not bending the curve yet. So, when we wrote the paper, we tried to use that term, but it's not, we have not get to, still need more time to get to the 80s level to the 50s level of the biological condition.
Okay, but what broader lessons can other countries draw from the Yangtze experience? Do you think this approach can also be applied to other major river systems that are also facing biodiversity loss, such as the Mekong River or the Amazon?
Yes, I would say yes, it definitely can have some, broader lessons for river conservations around the world, especially for those experiencing overfishing like the Yangtze. For example, you just mentioned the Mekong, the Amazon, and some of the larger rivers in Africa. They are very heavily being exploited, by local fishermen. So they are sharing a same issue, overfishing in these river basins. So they definitely can test or try the similar approach in some of the river basins in their region. But we mentioned that in our paper, if they want to try this, they want to make sure the local communities have enough food. For example, in the Mekong or Amazon or Africa, the countries they are largely depend on fish for proteins, for the food. So if they can provide the benefits for the local communities, they definitely can do the similar things like we are doing in Yangtze.
Yeah, and the fishing ban has reduced one major source of pressure on the ecosystem. You mentioned other factors just now, like the dams, the transportation, but we know that climate change continues to reshape river systems globally. So, how might a warming climate affect the Yangtze River's long-term recovery?
Actually, we mentioned fishing activities, and also we mentioned the dams, navigation. In the past, we have sand mining as well. We have the urbanization, agriculture. They are all related to human activities. We call them human stresses. One of the important thing is climate change. This is sometimes related to hydrology. We know the dams. We put the dams, we change the hydrological condition, and the climate change, actually play a big role. For example, the droughts, the flooding. We are all changing the hydrological condition, especially for the droughts. In the actually, if I remember correctly, it's 2022. We experienced a really large drought, not only in Yangtze but all over the world. In some of the Yangtze mainstem subchannels, it's been dry. And people can even walk, along the side channel, and that's a very big challenge for fish and other aquatic animals in the water. So, especially for in recent years, we see a trend for the warming, the extreme climate conditions. They will definitely affect the recovery, if they have really strong impact on that, especially for the drought and the extreme climate conditions.
Okay, Professor Chen, thank you so much for joining us today.
Thank you.
And that wraps up this edition of Climate Watch. You can find more episodes on your favorite podcast platforms. Just search for Climate Watch and hit subscribe. Don't forget to leave us a quick review or share it with a friend. You can also email us at radio@cgtn.com with your questions or feedback. And stay updated on the latest climate stories with our Substack newsletter, Climate Choices. I'm Zhao Ying. Thank you so much for listening. See you next time.